How to find the quadratic functions given the following conditions? First, table of values, given a graph, and given zeros. So expectedly, our answers will be written in y is equal to ax squared plus bx plus c, or y is equal to a times quantity x minus h squared plus k. In some other references, it is called the standard form of quadratic function, and this one is the vertex form of a quadratic function. Okay, so to solve or to find the equation using the table of values, first we're going to examine our x values if it is in consecutive order. Negative 1, 0, 1, 2, 3, so it is in consecutive order. Then let's examine our y values. We will just find the difference or subtract them. 11 minus 7 is 4, 7 minus 5 is 2, 5 minus 5 is 0, and 5 minus 7 is negative 2. That is the first difference. We'll subtract them again. 4 minus 2 is 2, 2 minus 0 is 2, 0 minus negative 2 is positive 2. So that is the second difference. Notice that the second difference are the same. So this tells us that the equations or the functions of these x and y values is a quadratic functions. Otherwise, it is not a quadratic functions if they are not the same. Okay, so how are we going to find it? We're going to write our answer in this form. The y is equal to ax squared plus bx plus c. I highlighted a, b, and c because we're going to find them since in our equation x and y are written as x and y. So to find a, we will just divide the second difference divided by a constant 2. Then c here represents the y-intercept. Then this x and y here are on the table values. Okay, so let's start finding a, b, c. So started with a. So since to find a, we will just divide second difference, which in this case it is 2, divided by the constant 2, and 2 divided by 2 is 1. So our a is 1. So next, since b, it is impossible to get the b for now, so we'll skip that. So we'll proceed to c. Since c here is y-intercept, and when we say y-intercept, the x values is 0. Since we have here x values which is 0, so the corresponding value of y, that will be our y-intercept. So our c here is 7. Then since x and y, we have available values here, so we will just choose any of them. So I prefer to use 1, 5 to be my xy. So my x is 1 and my y is 5. Since b is the only variable unknown, so we can get this, we can solve this algebraically using this function. So let's find for b. So we'll just substitute the values of its corresponding variables. Then after substitution, simplify. So 1 squared is 1. 1 times 1 is 1. Then b times 1 here is b. Write down 7 and 5. Then 1 plus 7 here is 8. Then minus 8 to both sides. So b is left and 5 minus 8 is negative 3. So this is supposed to be negative 3. I'm sorry. Okay, so we are now on the last phase, which is the finding of or the writing of quadratic function since all the variables are given. Okay, so we'll just write this again and substitute only for a, b, and c except x and y because we are writing the quadratic function. So simplify. 1 times x squared is x squared, then positive times negative is negative 3x, then positive 7 right down, and this will be our quadratic function. Okay, how are we going to find the quadratic function given the graph? So in this case, we're going to use the vertex form. Okay, so I highlighted the a, h, and k because we're going to find them, and as well as the x and y. So how are we going to find a? As of now, we cannot find it yet, but hk is known. Why? This hk here represents our vertex, wherein our vertex here is known, which is 3, negative 4. So we can immediately write 3, positive 3 to our h, and this will be our k, the negative 4. Then we can choose any xy here since we have 4 points known. So I prefer to use this one, which is 6, 5. It is in coordinate 6, 5. So 6 will be my x and 5 will be my y. Since a is the only variable unknown, so we can solve it algebraically using this vertex form. So let's find for a. So we'll just substitute these variables. So to solve for a, we will just simplify. 6 minus 3 is 3. Then 3 times 3, or 3 squared is 9. 9 times a is 9a. write down negative 4 and write down 5. Then since we're looking for 9a, we're looking for a, we'll add both sides by 4. So that 9a is left, then 5 plus 4 is 9. Then finally, divide both sides by 9. So that a is left, then 9 divided by 9 is 1. So we have here a is equal to 1. So they are now complete. We are now on the last phase, which is writing the quadratic equation. So write this function again and substitute the corresponding values, except the x and y. So our a is 1, our h is 3, our k is negative 4. Then simplify. This 1 times x minus 3 squared is still x minus 3 squared. Write down minus 4 and write down y, and this will be our quadratic functions. Okay, so how are we going to get the quadratic functions given the zeros? So remember, this x here, this negative 2 here is the value of x, wherein this 5 is also a value of x. And we know that they came from these forms. Okay, so we are just actually working backwards from our previous lessons and finding the zeros given a quadratic function. Okay, so this can be written in this form, and if you're going to multiply them, that is x squared minus 3x minus 10 is equal to 0. Since we are looking for the quadratic function, we'll just change this 0 into y to make it a quadratic function, then reverse them because you want it to be written this way. So y is written first, so y is equal to x squared minus 3x minus 10, and that will be our quadratic function. So we have an alternative way. It's up to you if you want to use this one. Remember the sum and product of roots. We can apply our skills in this kind of problem. So we know that the sum is negative b over a, and the product is c over a. So to find the sum of the root, since our root is negative 2 and 5, so negative 2 plus 5 is 3. And the product, when you multiply them, negative 2 times 5, that's negative 10. Okay, since we know that this is the quadratic function form, so if we're going to divide it both sides by a, okay, then this gives us 0 is equal to x squared plus b over ax plus c over a, wherein this b over a is the sum and c over a is the product. So we'll just replace this b over a with 3 and this c over a with negative 10, and we already have our quadratic equation. So why we get the opposite of negative 3? Because the sum is negative ba. Negative means opposite. So whatever the sum, we will get its opposite. Then whatever the product, we'll just write it at is, negative 10. Since you want to express it in functions, so we'll just change 0 into y, then simplify x squared minus 3x minus 10, and we have our quadratic function.